the central processing unit. It's the hardware that is responsible for taking, interpreting, and executing instructions from programs. So it executes code, okay? And the process in which it does its job is fetching, decoding, and executing. And these processes operate on every single devices with CPUs, and we need to understand this in a simple and understandable and memorable way. So firstly, you need to know that CPU is a very, very super powerful calculator. From whatever is decoded to the execution stage, the CPU essentially calculates machine code. It is given instructions by the RAM to calculate machine code. It's a very, very powerful calculator. And let's look at the CPU cycle, the fetching, decoding, and running processes. These are the three main processes that take place at the CPU. Firstly, the process of fetching involves the CPU fetching instructions from programs from the RAM, a memory location, where instructions are stored on a temporary basis. And the CPU mainly talks to the RAM to get its input. And the instructions from the RAM is now stored in the CPU's memory location known as an immediate access RAM. So it's another type of RAM that's different from the RAM it's getting instructions from. So the instructions from the RAM are stored in the CPU's RAM. The instructions are then passed into what is known as an instructions register in your CPU. And that essentially acts as another layer of caching in order for your CPU to execute things on a quicker basis. Caching allows for things to happen quicker, reduces delay time in these connections. And then you've got decoding. This process takes instructions from the instructions register into an interpretable form so that it can be executed by the CPU or the ALU unit in the CPU. And the thing you need to know is that when it comes to executing, the ALU, the executing unit within the CPU, can only process machine code. As a result, whatever instruction that is received at the instructions register must be understood by the arithmetic and logic unit, the ALU, okay? And these are typically arithmetic calculations, ones and zeros, binary stuff. And whatever is calculated is released as an output to the devices that it may impact, okay? So the executed instructions, as I mentioned before, can involve things like basic arithmetic, comparing numbers together, and moving them around in memory, okay? And as a result, these calculations are very simple, but they must be understood by the ALU. So that's why you need your decoder process. These calculations take place billions of times per second per CPU, and it's absolutely insane. As a result, I want you to remember the CPU as a super duper fast calculator. And as you can see here, there are two components that are critical for the data flow inside the CPU, and these two components make up the control unit of the CPU, and these are the decoder and the multiplexer. It links up the key channels within the CPU, and that allows it to basically dictate the flow of data within the CPU. So pretty much the two most important parts of your computer, your CPU, is your decoder and your multiplexer, because that allows for the balance and flow of information within your CPU and allows it to operate effectively. The CPU is also known as a microprocessor nowadays. In the past, CPUs were made of very, very many different integrated circuits that are connected within a circuit board, but now it's a single integrated circuit. So that's why it's called a microprocessor all-in-one. Okay, now CPUs are found in all devices and mainly for control and monitoring purposes. Okay, so whatever thing that can dictate the output of another device or to monitor to gather input, you need a CPU.